Okay, well, I'll do a couple of these, and then you can continue to do these today. I can't remember in your class. Jan, would you look to see if we've got a little baby quiz today? Because I can't remember. This one.
No quiz, Jeff.
Okay. This one right here, I wouldn't do the British method on this one. I wouldn't. Because the guess and check, there's only a choice, not even a choice. There's only one pair and one pair. This one I might use and I will do the British method, the grouping method. So this one, I'll say traditional. Really that's 6.3. And I'll use this one, grouping, AKA British. All right, so this one here, 1 and 3, or 3 and 1. This one here is 2 and 1. So you take, GCF, is there a greatest common factor? It doesn't look like it. Okay, so I go like this, put the signs in, both positive. Okay, 2 and 1. So I'll put a 2x here and an x right here. Now, I have a 1 and 3 or 3 and 1. The decision is, and I think some of you can see this ahead of time, do I put the 3 or the 1 here and then the other one over here so that when I'm done, I get 5? The 3 should go here. If I put the 3 over here, that would be 6. That's too much. So I can put 3 there and 1 there, and I think I'm done, D-O-N-E. Again, it's inner 3x, outer 5x. I said that. I wanted to go for the answer too fast. Outer 2x. And there's your 5x, which is what my target is. My target's always the middle term. So, I mean, why beat this thing up with going 2 times 3 and doing a grouping? To me, that's a little more work than necessary. But this one here, if I went 4 times 21, that's what, 84? And bust this up. So now I'm trying to get pairs, so I get an 8. I'm trying to get pairs, 1 and 84. That's not going to be it. 2 and 42, no. Does 3 go into that? Don't know. See, and I just take my calculator. I don't know. 84 divided by 3. Oh, yeah. So 3 and 28, but that's not going to be a pair that gives me 8. Now, when I say a pair gives me 8, if I add that, that's 31. That's far from 8. If I subtract these, it's 25. Still not there. 4, okay, that would be the 21. 5, no. 6, I don't know. 6, I don't know. Yeah, 6 and 14. I think that's it. See, if I subtract those, I get 8. So then I go over here and I go 4x squared. So instead of 8x, I need to write this with the 6x and a 14x in such a way that the signs have to be something so that I get negative. So let's do that. So I get negative 8x and then subtract 21. And then you do the grouping. Always put a plus sign. GCF for 2 and an X. Pull out a negative 7. Oh, that's good, guaranteed. All right, write down the 2x plus 3. And then what's left over is a 2x subtract 7. Hey, Russ, were you successful in getting that scan? You want to, I don't know how we share it. If you want to send it to me, and then if you send it to me by email, whatever it was done, and then I can upload it and share it with everybody else. Yeah, you're muted.
I'm trying to get back to you, Jeff.
So if you emailed it to me.
I scanned it upside down.
Oh.
But Jan, if it was what I was talking about was number 30 that we did together this morning.
Yeah.
Is that the British way, or is that the way?
Yes.
Okay.
Here, I'll show you guys number 30.
I'm sorry, Jeff. It just didn't.
That's okay. That's all right.
Okay, here's number 30. Let's see here. Come on. There. So that's the British way. Yeah, Jeff?
I'm looking. I'll speak again, Jan.
That's the British way?
Yeah, well, I just needed to know how to pin you so that I can.
Oh, gotcha. Yeah.
Okay. All right. Let's see. Yeah, multiply. Yes. Yeah. That's the British way. That's the grouping method. So yeah, Russ, it looks like Audrey, however way she described it to you, is that what Audrey showed you, Russ?
That's what she showed me. But when I started it, out there, I put an ABC, and then I put 2 minus 1 minus 6. So.
Well, if that works for you, then you can call it the ABC method, because what you're showing me.
Yeah, I mean, I didn't know what it was called.
Can I have that? No, British.
So I'm good with that. You're good with that. Did you understand how Audrey showed you? Okay, that's good. Thanks, Jan.
Yeah.
Okay, let's go back to what we're going to do today, which is 6.5 and 6, if I'm not mistaken. Is that what's on my assignment schedule, Jan? I'm not prepared this morning.
Okay. Yes, you're going to do 6. Yep, 6.5 and 6.6.
All right. So it's more factoring. 6.5 is a new factoring technique, and then 6.6 uses our factoring to do something. And I suppose, let's do one more of these, something that's different. This one looks a little different. I'll do one more of these. G. GCF, no. I'll do the grouping, which means I'm going to multiply 30 and 3. So 30 times 3, 90. I'm targeting 23. Now, if it doesn't work, I don't find any pairs, you're probably going to have to say it's prime. If I can't get anything that gives me 23, then it's likely prime. 1 and 90, that's not it. 2 and 45, no. 3 and 30, nope. Does 4 go into that? I don't know. I don't think so. No. 5 does. Oh, so you got 90 divided by 5 and 18. I think that's it. Yep, that's it. So then I'm going to go 30 x squared. So instead of this, I have 5x and 18x. And to get a 23, I have to have them both negative to get negative 23. And then plus 3. And then group. Always put a plus. factor. Okay, I'm definitely going to pull out a 3, but I want this to be positive 6. I want that to be positive 6x right here. So I'll pull the negative off, which changes the sign. Pull a negative and pull the 3 off. So I pull off a negative and a 3. That leaves me a positive 6x. And I pull off the 3, which leaves me a 1. And I pull off a negative off a positive, which leaves me a negative. Huh. A positive is 2 negatives. So I pull one of them off, there's still one left over. And then finally we go 6x subtract 1, 5x subtract 3. And how do you know if that's right? You foil. You end up foiling. All right, now flip the page. All of you see what I'm doing?
Yep, we can see it.
So we've done this always first, done this 4 terms, done this trinomial 3 terms. Now we're doing this, which the number 2 indicates to me 2 terms. So we're going to do 2 terms, and it's called the difference of squares, or the difference of 2 squares. So there's probably the easiest of all the factoring methods. You write down in descending order, of course, factor out the GCF if there is one. Then you check to see if they're both perfect squares. So perfect squares means the power of 2. And 4 is a perfect squared number, perfect squared numbers. Perfect squares. Okay, the number 0 is a perfect square. The number 1, the number 4, the number 9. It's because 0 times 0, because this is 0 squared, and this is 1 squared, and this is 2 squared, and this is 3 squared, and then 4 squared. So 16 is a perfect squared number. So if I had a perfect squared number, then whatever you get here, which your factor is a 4, so you're going to end up saying 2 times 2. Don't do 4 and 1, but do 2 times 2. That's where it comes in. They look identical, but opposite signs. They will be the same, and the opposite signs would be the middle piece, not both of them. See, x plus 2 won't be negative x and a negative 2. It won't be. It's the opposite signs are what's inside here, but you're done. And then how do you know? You do FOIL. So you go x squared minus 2x plus 2x. See, those go away. Minus 4. These go away. So you got your x squared, subtract 4, check, because that's the original. The fastest factoring method, easiest. Now you just have to recognize that these are difference. Okay, now the word difference implies subtraction. For instance, way down here, you have no factoring method. I didn't say sum of 2 squares. I didn't say that. It's difference of 2 squares. So you say, well, what happens there, Jeff? Some of you are going to try this. You'll say, well, Jeff says this is one of the easy ones. I'm wondering, I bet you somebody's going to do this and then walk away, and that's going to be in the multiple choice test. This answer right here will be there. Someone's going to pick it, and it's wrong. Now, how do you know it's wrong? You check it. If you foil this, it will not go back here. Here, check, check. Okay, x squared, sure, what's wrong with that? Nothing. 3x plus 3x, that's the problem, because that's 6x. There is no 6x up there. So that's not good. Sum of squares doesn't factor, it's prime. You could say this is prime. But Jeff, you didn't come up with all the different arrangements. Okay, fine. Then try this. Try x plus 9 and x plus 1. It's not going to work. You're missing the middle term. It's not a trinomial. So sum of squares is prime. Sum of squares, SQUA, is prime. Sum of squares is prime. Now, if I go back to A, that's the difference. And 121 is a perfect square. It's 11 times 11. And no GCF. So they look identically the same. They're just opposite signs. And it doesn't matter where you put the negative and which one's the positive. So negative here, positive there, and then you're finished. Okay, GCF, no. Do you want to do grouping on this? No. Trial and error, it's not a trinomial, no. Difference, maybe, of two squares. 4 is a perfect square and 9 is a perfect square, and I see an x squared. Yep, difference of squares. So what's inside the parentheses are two binomials. They look identical. They have to be identical. So you can't put a 4 here because you can't put a 4 there. How about 2 and an x and a 2 and an x and a 3 and a 3? Now they look identical, opposite signs inside. Put a plus here and a minus there, and you're done. Difference of squares? Maybe. There's a difference. 100 is 10 times 10. 81 is 9 times 9. So far, so good. X squared. Oh, look, I get an extra variable, y squared. But they both have powers of 2, so perfect squares. So this would be 10x and a 9y. And again, one's a positive, one's a negative, and I'm done. Not a lot to this. This one's a little different because remember, you always got to check the greatest common factor first, which there is. This one has a greatest common factor of what, 2? So you take the 2 out first and you're left with the 25 x squared, subtract 9. And what's left over inside, you can do something more. So you're not finished yet. Factor completely means go as far as you can. So the 2 just hangs out at the end. And because what's inside the binomial is the difference of two squares, there's a positive and a negative. 3 and a 3 in the back, 5x and 5x. And now you're done. And then letter F, okay, what's the first factoring technique that we always try? Number 1, GCF. And this one has a GCF. Okay, now what's inside? Let's see, go through the other factoring methods. Do we do grouping? Need 4 terms. This doesn't have 4 terms, it has 2. Okay, no grouping. What's the next one? Trial and error. Trial and error. Trinomial. Is that a trinomial of 3 terms? Nope. Let's see, what's the next one after that on your list? Difference of 2 squares. There's no difference right here. Nope. Matter of fact, that's a sum of 2 squares, and that's prime. So what's inside cannot be factored, but don't say the original's prime because you factored something. What's the point? Well, that's your answer right there. You factored something. So you don't say prime as an answer. This would be an answer. This one's prime because you couldn't do a darn thing to begin with. So that's the difference between the word prime. Sum of squares itself is prime, but this problem here would be boxed as 2 parentheses x squared plus 1. Now in your textbook, The title in your textbook is Factoring Binomials. And here's the difference of two squares, and you can see how it does it this way. And, you know, they give you some examples down here to try out. And you try out some kind of thing. Okay, practice. And they even have a couple kind of hard ones right here. Right here. Factor that. Okay, so, this is a difference of squares. Since x to the fourth is the same as x squared times x squared. X to the fourth is x squared times x squared. So they're identically the same. X to the sixth, you need, I said x, sorry. Y to the sixth. All right, so can you come up with two y bases that the powers are identically the same when you multiply them? You get y to the sixth. Yet y to the third, back in chapter 5, y to the third times y to the third, you add the exponents. Oh, y to the sixth. This is the difference of squares. So they go over here and say, here, blue and red, they look identical, opposite signs. What do you say about this one? Prime. I'm wondering what the author says here. Oh, that's letter A. Letter B. Letter B. Let's see what letter B says. Note that the binomial is a sum of squares. Since we might try factoring. You might try that or that. When you multiply it, you don't get the original. So prime, see, they even do that one, prime. So they do a number of examples. Now in 6.5, there's something called, because you're talking about factoring binomials, there's another set of binomials which would be called the difference in sum of two cubes. I'm not required in this modified or changed beginning algebra course. You probably didn't realize this if you're fairly new to SRJC, especially the math department. We used to have other courses, probably about a year and a half ago when we converted into new ones. Other courses that, one was called Math 151. I'll just start with that. It was a 5-unit class that covered a lot more material. And so we trimmed that down. So it's a 4-unit class. So we eliminated some sections. And that's what we're doing right now. I am not covering this, nor do I have to. So the sum and difference of cubes, you're not responsible for. Only the difference of squares is a factorable binomial. Okay, that's that. There you go. All right, fine. I'm not doing this. And Jan, could you do me a favor? Could you look to see if I assigned any difference or sum of cube problems in the homework?
Yes.
And if so, we need to eliminate those.
Okay.
So difference of squares, we're not doing sum or difference of cubes, not doing them. So you can scratch that off. Scratch these off. So that takes care of 6.5. I'm done. Just the difference of squares. So that leads us to 6.6. 6.6 is now solving. They call them quadratic. here's the thing about quadratic equations. Quadratic, and there's even something called the quadratic formula. And there's even something next semester for you guys that are going on, let's say, to maybe 156. Quadratic functions, whatever the heck a function is. So the word quadratic comes up a lot. And it has nothing to do with 4. I mean, for you to worry about. Nothing to do with 4. You think quad means 4, which it does in most instances. It's a title someone gave it, and so we just live with it. The degree is 2. Quadratic means it's a degree 2 polynomial. Degree 2 polynomial. Well, let's see. Is that a degree 2 polynomial with an equal sign? Yes, it is. Highest degree is. And let me flip over here. Is that a degree 2 polynomial? Yes, it is. Degree 2, yes. Degree 2, yes. Degree 2, yes. Degree 2, yes. This is kind of a weird one, but if you FOILed it or distributed it, would it be a degree 2 highest? Yes. So they're all degree 2. This one here, I'll handle it differently. It's not a degree 2 polynomial, so it wouldn't be called a quadratic equation. It's a cubic. You can look at the degree. It's a cubic equation. We'll do 1 or 2 of these kinds. Most of them are going to be like 1 through 6. So your job on all these problems is to try to figure out an answer. Solving means you figure out an answer. Get the x by itself somehow. And factoring is going to be your method, factoring. So your job needs to make sure you get everything where it's set equal to 0. That's your job. Jan, did you find out if we've got, if I
Yeah, I
assign?
just put it in the chat. I put the number, the homework numbers, 24, 27, 30, 33, 39, and 45. Do not do those.
Thank you.
Mhm.
Thank you. Would you mind sending, because there might be a few people
Yeah,
that are not here, sending out an email or announcement?
I was just going to tell you I'll do it for both classes.
Thank you.
You're welcome.
So, okay, so you get so that looks like a trinomial, which that is, unless C is a 0, then it's a binomial. You will not be using grouping, like 4 terms. You won't have a method number 2. The grouping method, literally. It'll either be 2 terms or 3 terms. That's what you'll have. So let's see, this one here, I got to set it equal to 0. That's what it says, set it equal to 0. This one's not. So bring the 3 over to the left-hand side. Okay, and then you factor. This is called an easy one. You guys remember why I call it easy? Why is it called easy, Jan?
Because the coefficient in the first term is 1.
That's right. So 6.2. This is a 6. So easy. You don't need well, if you did grouping method, good. Okay, you can do that. It's as the British would say, it's very methodical, very systematic, guaranteed it'll work every time. But I think you can get there faster. Hey, the only choices for 3 is 3 and 1. All right, put a 3 there and a 1 there and come up with the signs that work. Then what you want to do is set each factor equal to 0. So the idea behind that is if what I boxed right there was 0, wouldn't 0 times it doesn't matter still equal to 0? If all of this was 0, 0 times anything is still 0. What if you put a 3 right there and a 3 right there, 3 right there and a 3 right there? Well, that's 0 times 4. Yeah, it's still 0. So you'd say x equals 3 is an answer, is a solution. So if you get it in factors, is the concept here, the method, you write each factor down equal to 0 and then solve for x. You solve these little baby equations. And these would be considered the solutions, the answers. And it turns out, which is true, the degree of the polynomial, if it's a quadratic, it's always degree 2. That means there's going to be 2 answers. And if the polynomial is a degree 3, 3 answers. If it's a degree 4, 4 answers, and so on. How many answers would I be looking for here? 3 answers. Three solutions. 2 solutions. I don't know. This one's the weird one. 2 solutions, because it's the power 2. 2 solutions. 2 solutions. 2 solutions. You find them by factoring. Okay, so here we go. Is this set up properly? What I mean is it set equal to 0? How about that one? How about that one? So this one has a little extra step you're going to have to do. How about that one? How about that one? So 5 and 4 have a little extra work before you get started on the factoring. This is what happens sometimes, Jan, a common mistake when I, like this one on the exam, because students aren't following that you gotta set it equal to 0 and it has to look like in a descending order. This is weird. They'll take x and say, well, x equals 4 and 2x minus 7 equals 4, and they'll solve that and not even check it to see if it works.
Tricky one.
It is a tricky one. Here, I said watch out for this one. I'll do this one first. Here, I'll show you. It's tricky. So what you're going to do is make it not so tricky. Distribute. So then you got, what, 2x squared subtract 7x equals 4. Oh, okay. Now it's not too bad, except I got to move the 4 over. So now you go 2x squared subtract 7x subtract 4 equals 0. And now you can factor, which maybe I'll do this. I'll factor this one. Not grouping. I'm not going to do the British on this one. The more you practice your problems, the better you get. I'll say the more. Okay, I gave you some problems to consider for the homework. Okay, that's just a sample. If I were a student and I know I would make the time to do as much as I need, so I would do all the odds because I have the answers in the back of the book. I do all the odds. So practice, practice, practice. So if I go, hey, 2x and x, I know that that's only one choice. And then I've got 4 and 1 and 2 and 2. I see 7. I think a 4 with the 2 is going to be an 8. I think that. I might as well put the 4 over here because that'll give me the 8. And if I put the 1 right here, as long as I go 8 subtract 7 or negative 8 plus 7, I said, sorry, 8 subtract 1, 7. But I need it to be negative. So here's the negative, there's the positive. I think I did it right, but I'm going to check to make sure. Inner, outer, inner, outer. 1 minus 8. 1 minus 8 is negative 7. Looks good. And then you take each piece and set it equal to 0 and finish up the problem. So you take 2x plus 1, set it equal to 0. X subtract 4. This one's easy. X equals 4. Okay, how do I get the x by itself? 2 steps. You subtract 1, then you divide by 2. You subtract 1, and then you divide by 2. So x is negative 1/2. How do I know that either one of them is an answer? Anybody have an idea? How do I know if both of them are answers, but how do I know if 4 is an answer? Anybody have an idea of what I should do other than Jan? How do I know if 4 is an answer? Peter, how do I know if 4 is an answer? What do you think? How do I know if that's really an answer?
I don't know, to be honest.
Okay, Annette, how would I know, Annette, if 4 is an answer?
I'm not either.
Why, Annette?
Jeff, can you put 4 in for X and figure it out?
Okay, so Annette, hold on a second, Russ. Annette, what do you think? How do you know if 4 is an answer? And Russ kind of gave you a little hint of maybe a direction.
Wait, add it back in.
Okay, add it back in where?
Put it, I'm not sure.
Okay, so Peter and Annette, not quite sure.
Do you,
Sarah, I see your name up there. Are you around? Are you around? Sarah Perez. Oh, and the only other one I see is Robin. Robin, I know more are out there, but that's all I see on my screen. Robin, how would you explain or defend or guarantee that that's an answer? What would you do?
Would you put the 4 in like next to the 7 or the 2? Exchange the X's?
Okay, I like how you're describing it. So I'm going to paraphrase a little bit. Take the 4, and she's looking back up here, I think, because she talked about the 7 and the 2. Take the 4, and I think you meant is put the 4 right there where that X is. She said exchange.
Mm-hmm.
Okay, I like that idea. I'm going to add something extra for everybody to do. You plug it in. I think this is what Russ was kind of implying. You plug it in to the original. This is not the original. I could have made a mistake here with my distributing and collecting like terms. So you need to go all the way back to the original and make sure it works here. So Robin, you used the word exchange. Let's exchange the X's here for the 4 and see if the left-hand side here turns out to be 4. It's called checking. So if I check here, I'm going to take 4 and put it right here. And I go 2 times 4 subtract 7. I wonder if that equals 4. And now I'm going to do order of operations. So inside here, I have to do that first. Leave 4 alone. That's 8 subtract 7. I still wonder if that's 4. 8 subtract 7 is 1. Hey, sure enough, the left side is the right side. And that verifies that boxed answer.
May I ask where you got the negative the negative 4 from under the watch out for this one? You changed it from an equals 4 to a negative 4 above that one? Yeah, that one.
How do I move the 4 to the left-hand side? How do I make the 4 go away from the right-hand side? You subtract 4 from both sides.
Oh, okay. Thank you.
Subtract 4 from both sides. So if I subtract 4 from itself, you get 0 on the right. And if I subtract 4 over here, there's nothing to combine it with, so I leave it as subtract 4.
Thank you.
Yep. All right, now I want to box this. Boy, I'm really tempted. Supposedly that's the other answer too. So I still got to check that one. That's harder. You're scared because it's a fraction. Just be patient. Take your time. You guys can do it. So what do? We go, here's my check again. Check the original. Here's the original. Okay, I'm going to put negative 1/2 right here. I'll put negative 1/2 right here. So negative 1/2 times, parentheses, 2 times negative 1/2, and then still subtract 7, and it's supposed to still equal 4 when I'm done. Now, this is more work. Just got to make sure you know how to multiply fractions and use the order of operations. So in here, I'm going to do 2 times negative 1/2, or what's half of 2 with a negative? Negative 1. Negative 1. Half of 2 is 1. and it's got to be negative. Subtract 8, it's supposed to equal 4. Excuse me, subtract 7, my mistake. My brain's running faster than my hand, or my hand's running fast. Well, anyway, something weird happened. Okay, subtract 7, negative a half times, this is negative 8 here, it's supposed to equal 4. Okay, 2 negatives make a positive, check. And half of 8 is 4, check. Good answer. So highly recommend, highly suggest you check the original, rather than at this stage where Robin was thinking that it might have worked, Robin, and he'd say, hey, that all works, and I box this, and you know what? Most of you are just going to box your answers no matter what, unless I ask you on the group quiz, look at the instructions. If it says check your work or check your answers, that's part of your points, part of your process that I'm looking for. And if you fail to check correctly, then you don't get full credit on the group quiz on that problem.
Can I ask a question really quickly?
Sure.
This may sound like this is Randy. It may sound like a stupid question, but what is the point? Why do you want to get 0 in algebra? Like, what is the reason? Yeah, why? I mean, what is the reason? Is there a reason? There probably isn't a reason. Hold on, I'm on my Zoom. I'm gonna mute again.
Okay, what's the reason for algebra, period? Algebra is a problem-solving method. Okay, I want to find the square footage of my room. Okay, square footage. Why? Because I'm going to lay carpet, or I'm going to order carpet for the guy to, so that they deal with square yards, square foot, something like that. So you need to have some problem-solving skills, possibly. So here I've got what's called an equation. You can think of it as like width times length. Width times length. The width is 2, the length would have to be 2. That's a square, you know, for my room. So I'd have 4 square yards or something like that. So how do I solve for x? Well, then you go here, divide by 2, so it's a process, and then you say, well, this stuff here is old stuff for you guys. And you say, okay, well, I've done that. You know, that's boring. But gosh, I would say the first week, some of you are still a little nervous about solving this little baby equation. And then I'm saying, well, how do you know if it's the right answer? Well, you plug it in to the original. There's only one original, and it's an easy way to check. Now, what if I did this? Because you were saying, why is it set equal to 0? What if I moved the 4 over to the left-hand side? Seems a little weird, but what if I moved the 4 over to the left-hand side? So you'd have 2x minus 4 set equal to 0. Okay, so you have a problem that looks like this, and you're still trying to solve. So Randy, you'd move the 4 back over here, and then divide by 2. So what was the point of this? If I had 2x minus 4 set equal to 0, and say x plus 1 set equal to 0, I have 2 things right here. They could both be 0 to give me 0. One of these can be 0, and the other one could be anything else, and it's still 0. So, but to try to come up with the answers to this one, I either have to do it in my head, which I could, or I set each one equal to 0, like I did over here. I can do the same thing here. You can see it's probably -1. And so then you'd have 2 answers. Now, so here, because it's a product, I set it equal to 0, set it equal to 0. You're asking, why is it 0? Okay, I'm getting there. What if I had, and FOIL this out. What if I had, what, 2x squared minus 4 plus 2 minus 2x minus 4 set equal to 0? This is the kind of problem we're working with right now. Well, what if I had that and it was still equal to 0, but you're still wondering, why do we have to do a 0? Well, I'm saying that there's two answers. Good luck trying to find them. There's two answers. What are they? And in real life, you might have, I don't know, some need in some industry or some occupation that someone gives you a scenario that comes up with, hey, we got two answers. We want to find out if there's even possible an answer, but we have two possible answers. How do you find them? And so it's problem solving technique. Well, let's see, our technique is to factor that. So you can do that, it looks like this. And then I'm telling you, if you set each one of those equal to 0, you're going to come up with one of the answers to be 2, and the other one will be -1 when you finish that. What if I had, instead of this, and I moved the 4 over, and I had 2x squared subtract 2x equals 4, and that's the problem. I mean, that's the same as this, except it just set up differently. So if I cover this up, it says, okay, now there's still some answers. Find the answers. What do you do? A couple of you, maybe Randy yourself might be included, might say, well, that looks like something I can factor. And maybe you go about your business to say, well, I'll take the 2 and the x out, and I'll do this thing that Jeff is suggesting to factor the left-hand side. You're avoiding my rule. You're avoiding the rule that says you got to set it equal to 0 if you do it this way. Now, let's say you're resisting, even though resistance is futile. You're resisting and you're trying this, and you wonder if you get the same two answers. By the way, Randy, 2 works. Solving this, you still get a 2. It works. This is -1. X is a -1 is another answer. I know that x equals 2, by the way, and x equals -1 are the two answers that work for that. The two answers will work for that if I plug them in. And those two answers will work for that if I plug them in as well. Try the -1, for instance. -1 squared is +1 times 2. Okay, so you've got +2 there. -2 times -1 is +2. So I got +2, +2 is +4. That works. Now, if you did it this way, so ignore that. If you did it this way, because some students will do it, they'll say, hey, 2x equals 4. Doesn't that give me 2? Turns out it does. 2x equals 4. Jeff, that gave me 2. What's the big deal? Watch this. If you take that and solve for x, you get 5, and you'd think that that's an answer, and I'd say, check it. It won't work. This one will work. So this case, we got one that works and one doesn't, but there's two answers. Check it. Where do you check it? To the original. All right, so you plug it into the original up here. Put 5 in there. All right, well, that's 25 times 2 is 50. 50 minus 10 is 40, not 4. That one is bad. This one's okay. That one's bad. So I don't know. It's a long-winded, thing that says, what's the problem with this one? Well, you're apt to say x equals 4 and 2x minus 7 equals 4. And look at it. One of the answers is right, but the other one's not going to be -1/2. However, if you set it equal to 0, you will find both answers. You will find both of them, not just one. Like this one here. Just get the 16 to the left-hand side, and you'll find both correct answers. So that was a long-winded answer, Randy, excuse me. And if it still doesn't make sense, I'm sorry.
No, I mean, it sounds, so it's it's just a necessary problem solving technique for multiple variables. Is that basically the
Well, it's the same variable, but multiple terms.
multiple terms, quadratic? Okay, got
Right.
it.
Well,
Okay.
it could be multiple terms, could be a cubic, like this one here is a cubic. There's only 2 terms.
Right.
There could be 7 terms. There could be 7 terms. One variable is usually, for our level, is all you're going to get.
Okay.
And for this class here, we'd probably only going to get the maximum would be 3 terms, the maximum terms. So you'd either have 2 terms or 3 terms.
Okay.
In real life, we we talk about this actually in a Math 9 class. Math 9 is a class that's called, excuse me, I'm going to sneeze. You don't want to know that. Now that you're looking at me, I'm sneezing. I can't sneeze. Math 9. I hate that when I can't sneeze. Math 9 is they call it finite math. It's for business majors and econ majors usually. Math 9. It's a very fun class because it's real life problem solving kinds of big word problems like statistics, real life math. So in a section, they deal with multiple variables, not just one, but multiple variables. And you're trying to find the optimal solution that works for that particular equation with multiple variables. Think of Nike. Nike's let's say, just their tennis shoe division for men's. How many tennis shoes do they have? Oh my gosh, let's say 1,000. 1,000. And they're trying to decide whether they should keep all 1,000 models on display or sell them or not. Maybe there's some losers. They're losing money on them. So there's a technique with multiple variables that they learn in my Math 9 class to say, well, what decision are you going to make with multiple variables in an equation? I would like the best decision possible to eliminate the models that are losers. You know, they're not making any money. And I want to keep the ones that are winners. And so I'm sure companies like Nike have people behind the scenes making these decisions that are probably math trained, computer science, because it's probably it's computer software. Let's put it, someone's developed a software to help us do that. And those are really smart people that have learned those software engineer techniques. So this goes beyond our course, Randy. We're just doing a little problem solving. You have 2 terms, 3 terms, set it equal to 0, guaranteed it's going to work. I'm glad you asked the question, but it took me 15 minutes to answer. Let's do this one. Okay, I'm going to do that 6.4 technique, meaning that I'm going to, and maybe Russ calls it the ABC method or Audrey's method. I'm going to do Audrey's method. Take the 5 and the 8. Now set equal to 0, that's good, but take the 5 and the 8 and you get 40. And you get the choices of 40. I'm looking for 6. 40, I'm looking for 6. I might even be able to come up with the combination that gives me 6. 40, let's see. 40, 5 and 8 is not 6. Okay, 4 and 10. 4 and 10. See, I guessed it. I didn't have to run through all of them. 4 and 10 is going to give me 6. I just have to put the sign correctly in the right place. So, okay, so instead of -6, I'm going to write it as +4 and -10. That gives me -6. And subtract 8, still set equal to 0. Grouping. plus negative 10x subtract 8 equals 0. Factor. I'll take a negative and a 2 out. I'll take a negative and a 2 out, so that'll leave me the 5x plus 4. Okay, write down the 5x plus 4 once, and the leftover. And now I set each piece equal to 0. And you can probably guess what that one is without even doing anything. 2. 2. Answer's 2. This one here is a little harder. A few of you could actually come up with the fractional answer. In my mind, without writing, I'll write it down and show you, but you know, in a student's mind, maybe some of your minds, you'd say, gosh, if I wrote 5x plus 4 equals 0, how do you get the x by itself? You move the 4 first, and you move the 5. You move the 4, then move the 5. You subtract the 4 and divide by 5. Negative 4 over 5. Negative 4 over 5. There's one of your answers. I'll show you how to do it algebra, but that's what I do. How do I get the 2 away? Add 2, positive 2, positive 2, positive 2. Now, how do I get that with the algebra? Okay, you take the 5x plus 4. Some of you need the structure, that's fine. You take the 5x plus 4, you set it equal to the 0, and you solve for x. There's a baby step. Okay, and then here comes the next baby step. You divide by 5.
Move that over a little, Jeff.
Thank you. It's the same thing I boxed over there. I just circled that one. So whatever you guys need, if you need all the baby steps, I call them baby steps. You need all the steps, good. That's a good thing. Nothing wrong with that. And a few of you can do this.
Hey, Jeff, I think you're muted.
I didn't touch it.
Huh.
I have no idea what I didn't say. What didn't you hear me, Jan?
How would I know?
I don't know either. What was the last thing you heard from me before I got muted?
Well, you boxed and you circled.
Okay.
And
Well,
then,
okay. Those are the 2 answers.
yeah.
And that's the same answer over here, but using a bunch of baby steps. And if you need the baby steps, go for it. That's nothing wrong with that. And maybe 1 or 2 understood my concept of just talking it out and coming up with the same answer. But be careful doing this in your head, because I make mistakes in my head without writing it down. So just be careful. Okay, I'm going to do one more, and then Jan can do the other ones. Let's see, one more. I'll do this one up here.
I think, Jeff, you were going to do number 4.
Yeah, I was going to do number 4. I'll let you do that one.
Okay.
That's a biggie. I'll let you do that one.
Gee, thanks.
Yeah, you're welcome. I did number 5. That was, hard enough in a way.
Yeah.
And I did this one with the grouping method. Yeah, if you do number 4, Jan, you might do the grouping. I don't think there's a GCF, but I think that's a good one for you to do. This one's not too bad. That's pretty easy. And then you can do number 7 as well. All right, number 1. Is it set equal to 0? Mm-hmm. Is it in descending order of power? Mm-hmm. Is there a greatest common factor? Mm-hmm. So take the x out. Okay, fine. Okay, this would be 5x subtract 2 left over. Could I put a parentheses around the x? Mm-hmm. So it kind of feels, what it does, this kind of feels like 2 parentheses right here. See how there's 2 parentheses and you set each one equal to 0? like over here. See, here's 2 parentheses, and you set each one equal to 0. So now I've got 2 parentheses. See, the power of 2 says I've got 2 answers. So 2 parentheses, set each one equal to 0. So x equal to 0, parentheses. X equal to 0, and parentheses, 5x subtract 2 is equal to 0. Well, there's one of the answers right there. It's the baby one. Well, okay, easy one, I should say baby, but the easy one. How do I know if that works? Well, stick it back in the original right up here. Okay, yeah, sure, that's going to be 0 equals 0. So x equals 0. Okay, how do I solve this one with steps? Instead of doing it in my head with steps, you add 2 and divide by 5. And if you want to know if it's the answer, you plug it back into the original. Don't plug it back into here. Don't plug it back into here. Plug it back into the original, just to make sure. Okay. Stop my share. So Jan said there's no little quiz today. And I'm going to check something here. And then I have an announcement to make too. You don't know what I'm looking at, that's okay. Yeah, that one's on it. Okay, let me get that away. So here's my announcement. There's going to be a day that'll be coming up, and I'll be sending you an email with regards to what I'm saying. There's going to be a day coming up that I will not be here in class or live. I won't be live. I'm going to record my lecture, and you'll be watching it during our class time. You can watch it sooner than that too, but I'm going to, how I'm doing this lecture right now, in lieu of me being live, you're going to see me in a recording. And there'll be a link and there'll be a location in Canvas where to find that. And I'll give you instructions on that. So there'll be a day coming up. There might be one more day, Jan 2, down the road for this class. I think in November, it happens again. So if that's the case, the instructions for you will be go see Jan before class, like normal, so you can, keep up and have questions on it. The window of time that I normally would do live lecture, that's the time you could dedicate to watch the video, which will be on the topics. And then when you're done, then Jan will be available, like she always is, outside to answer any questions for you. So just to be aware that there'll be a day, you get a notification on that and some instructions on where to find the video and what to do.
And then you want me to be available for that second hour. I'll be doing that second hour, right?
Yeah, that's what I meant. Well, that's what I was trying to say. She'll be there at the beginning before class like she normally is. And just like normal, like right now, Jan will be taking off and going into her room, her Zoom, and you would find her there. So the second hour of the time that I'm not here, second hour will be with Jan, like normal. Like normal. But that's not this week coming up. I think this week, our next class, let's see if this is you guys here.
Quiz on Monday and then exam on Wednesday.
Is that what it is? Yeah, this is Math 25. I don't want that one there. Yeah, let's double check here. Yeah, today's Wednesday, huh?
Yeah.
We're done with this week for this class. I think we're halfway done. In terms of time, we're halfway done. It should be pretty close to halfway done with the material too. When I finish chapter 6, that's usually I'm halfway done. So we're We're halfway done. Assignment. You guys are Monday, Wednesday. You don't know what I'm looking. I'm looking at your assignment schedule. Yeah, October 12th. Yeah, so Monday. Monday's your group quiz. And your group quiz will be released on Sunday, whatever time I have it released. So you have 24 hours to look at it so that Monday you can come and polish it up and talk to other people. Then it looks like Wednesday, the 14th, so a week from today, is your exam number 2. And your homework also. Don't forget your homework will have to be turned in. Okay, that's all I got. I'll stick around for any individual questions. Jan will head off into the other world.
And the link is in the chat.
Okay, thanks for doing that, Jan.
Yep.
Otherwise, have a great weekend for the rest of you.
Hey, Jeff, quick question.
Sure.
On 6.5, if we've already done a couple of those problems that Jan put up there, do you want us to rewrite the homework and leave off, or?
Oh, yeah, it doesn't matter. I won't look. So if you've already done the homework and attempted or work
I've
those,
only done a few of them. So,
that's fine. That's fine. You just won't get any on the exam,
okay.
nor the group quiz.
Okay. So, I mean, I came up, I think I did, I had Math Lab walk me through it, the tutorial department, but I came up with a couple of different terms. One's a binomial term, and then it's trinomial term.
Right. That's the case. You'll get a binomial and a trinomial every time for the cube.
Okay.
The cubes. That's
Okay,
true.
so I am on the right track. We just don't need to do them. Okay. All right. Thank you.
You're welcome, Russ. Okay.